Hi there. Welcome to the solutions guide for our quiz we just took. Hopefully this covers everything for you, and if you have any questions, you can always ask during class, obviously. I'll try and breeze through this within a half hour, but it'll be very, very difficult, so just bear with me. Okay, problem number 1. We had a scalene triangle, and I didn't write this, but hopefully you saw it in the book. It means no sides or no angles are congruent, unlike that of an isosceles or equilateral triangle. I labeled P here for you. It's on the midpoint of this segment MO, and we have this line L, and MN, segment MN, lies on it. So we're going to do two things. First thing we're going to do is we will reflect this triangle across this line to generate this transformation right here. So hopefully you remember something about reflections here. If I'm reflecting across this, I want to be looking at the mirror image of it. Now, we learned that M and N, because they're on the line, they won't change their position. O will, however. O prime will be over here. I'll go ahead and drag it over. And it probably looks about like that. So the question is, once you get this four-sided shape here, disregarding this middle part, what shape is this? And I ask you to explain how you know, but what you really have to know is that, this is a kite. And what you have to know is that this segment is congruent to this segment. Let's name this O prime. And this segment is congruent to this segment. You have to remember you are looking into a mirror. So while this might not be drawn to scale per se, this is congruent to that, that's congruent to that. And hopefully you remember something about kites, or you at least saw it in the book during the quiz. Okay? So as far as explain how you know, if you did this right here, or if you talked about kites the way I just did, or you said something like this, and O, something like that, and did it for that one as well, then that works too. Okay, the next one here is a rotation. And you have to rotate this 180 degrees about point P to generate this transformation. Now, I can go ahead and, like I said, I can cheat with this. I have another triangle already created. And I'm just going to rotate it 180 degrees. Now, I didn't do it about point P, but I did the 180 degree rotation. This would be about point P. Hopefully you did that correctly. And you say, well, what's this four-sided shape now? Hopefully you can tell. You might say, and I don't remember if it's actually one of the answers. I don't think it was. But you might say rhombus. And we said it's a scalene triangle, so that means these are not congruent. So that's congruent to that, and this is congruent to this. And that is a parallelogram. So hopefully you put that. And again, for the same reasons, you state what a parallelogram has, like what properties it has, and then you also say opposite sides are congruent. And they also tend to be parallel as well. Okay, number 2. Rotate the below preimage y degrees counterclockwise about point C. Okay, for starters, this is counterclockwise, so hopefully you know that. After that, it doesn't really matter how many degrees it is. Like, this says y, and we're like, well, it's y. Well, that's not what's important. What's important is that you do see how big y is and where y ends up and everything like that. So hopefully you can notice this much. You're going to rotate your circle that many degrees that way for everything, and everything else out here as well. So one thing you should see is that this is a tangent line and it's horizontal. That means that its imaginary radius going up to C is straight down. So when I rotate y, this diameter is rotating like this. And when I rotate y degrees counterclockwise, it should be straight up and down. So I'll go ahead and draw that first. And it won't be completely accurate. In fact, that's not even close, but okay. And then after that, this line rotates a little bit up here as well, and that one's not as important how accurate you are. So I'll just go ahead and get something kind of close. The other one that you do want to have accurately is on the outside right here. You want to have, I wish I could keep that thickness. You want to have, because this diameter rotated, now it's straight up and down, keep in mind this is a tangent line as well. And tangent line's 90 degrees from its radius that it touches. So this line should now be horizontal. It should now be up there. So that's the final thing that you really do want to mark correctly on there. And then if you have a line touching from this point to that point, that's cool too. So this is 38 degrees. Go ahead and write it. This is 38. This was x, and this was y. Now for bonus points, you could solve for x and y, and I'll just do it one quick way here for both of them. X is the arc right here. Sorry for the bad drawing. And this is its central angle, C, going from there to there. Right? So if we find the measure of that central angle, then x will be the exact same thing. So we do know that with radii and tangent lines, these are right angles. They're 90 degrees. So if those are both 90, and this quadrilateral right here adds up to 360 degrees, then that means that 38 plus the central angle equals 180 degrees. And since the central angle is as much as x, then x plus 38 equals 180. Subtract 38 and you get x is 142. To solve for y, x and y together form a semicircle. Because this is a diameter, you know this is 180, and so is this. So if x plus y is 180, you can either substitute x and do that, or you can say, so is x plus 38. X plus 38 is 180. X plus y is 180. Oh, y equals 38. So there you go. And hopefully you got some bonus points on that. Okay, this one has a little bit tricky wording, and it was just, it was more of the setup of the problem. So I give you an isosceles right triangle here, ABC. And I said, if you take this triangle and reflect it along this line, then C prime goes over here, and you end up getting another triangle that basically looks like this. You have C, C prime, A and A prime are on the same point, and B and B prime are on the same point. And what you end up creating is another bigger isosceles right triangle. I hope you can see it. Some people. So here are the two legs, and here's the long hypotenuse. And then I just basically transformed it and said, I took away all the extra markings and said, okay, here's that bigger right triangle. Obviously, it's smaller compared to this just by size, but it's really a bigger triangle. And then I said, go ahead and create another reflection along some line to make a bigger one as well. So let's go and do that. There are two segments you could have chosen. You could have chosen AC prime or AC. I'll go ahead and choose AC. Let me clone this. Okay. And then I'm going to reflect it. So let's see, how do I want to reflect that? Let me just go ahead and rotate this a bunch. Oops, I went the wrong way. Okay. So here would ultimately be my reflection. And hopefully you can see that. The A's are in the same place, the C's would be in the same place, etc. So here's now my bigger isosceles right triangle. Here's one leg congruent to that leg, and here's my right angle as well. So I'd say that I reflected across segment AC. And then I marked this up and drew that up. So hopefully you have something like that. You could have done AC prime, and you would have a triangle that goes like that. Okay, number 4. Triangle TSN is a 30, 60, 90 special right triangle. So you see that one right here. I marked the 30. I did not mark the 60. If you'd like to mark that, then that'd be cool. When the preimage of triangle TSN is translated using the following rule. So we start from whatever x and y we have. Let's say I looked at t here. You would shift it over to the right 6 units and up 7 units. It generates an isometric image where the vertex t prime is on the origin. So basically what that means is that you end up getting a second triangle, and I'll just kind of just judge it right there. You end up getting a second triangle, and the transformed t vertex is on the origin. Okay. Now we don't necessarily know where S is or where N